Welcome to this first video on the select statement. Now that we have set up our database and tables, it is time to dive into the fun part, retrieving data with the SQL select statement. This is your chance to play along, so grab your SQL editor or database tool and follow these steps. The select statement is the key to fetching information from your tables, letting you explore and analyze your data. In this do-it-yourself segment, we start with the simplest form of select, and you run these queries yourself to see the results in action. The easiest way to use select is to retrieve all columns from a table. We do this using the asterisk symbol, which acts as a wildcard to include every column in the table. For example, to fetch all records from our names table, you write select asterisk from names. Go ahead, type this query into your SQL editor and run it. If your names table has data like the ID, name, and city columns we added in the previous video, this command will display every column and row, giving you the full data set. For instance, you might see records like 1, Alice, New York, or 3, Carol, Chicago. Running select asterisk from names is a great way to explore your data, especially when you are getting started or checking what is in a table. However, it is not always the best approach, especially with large databases. Pulling every column can slow down your query, use more system resources, and make the output harder to read if the table has many columns. For example, if your names table has 10 columns but you only need the name and city, fetching all columns is overkill. Here are a few tips to keep in mind as you experiment. Always end your SQL statements with a semicolon. It is required in most databases to mark the end of a query. If your table is empty, the query will return no rows. That is okay. Double check your table name. If you get an error like, table not found, ensure the table exists and you are using the correct name. Case sensitivity matters in some databases. Now that you have tried fetching all columns with select asterisk from names, let us level up by learning how to retrieve only the specific data you need. This is a crucial skill in SQL, and you are going to practice it right now, so keep your SQL editor ready and follow along. While select asterisk is great for exploring small datasets or checking what is in a table, it is often overkill in real-world scenarios. Pulling every column can clutter your results, slow down your queries, and make it harder to find the information you care about. Instead, you can make your queries more focused by specifying exactly which columns to display, listing them after the select keyword. For example, if you only want the names and cities from our names table, you write select name, city from names. Go ahead, type this query into your SQL editor and run it. This command fetches only the name and city columns, leaving out others like ID. If your table has data, you will see a clean output like Alice, New York, or Carol, Chicago. Compare this to the select asterisk query you ran earlier. Notice how the results are more focused and easier to read. For a small table like names with just a few columns, skipping one column, like ID, might not seem like a big deal. You can still see everything at a glance. But imagine working with a massive table that has hundreds of columns and tens of thousands of rows. If you use select asterisk and only need, say, columns 5 and 114, you would be stuck scrolling left and right endlessly to find the data you want. That is not just frustrating, it is inefficient and can overwhelm you with irrelevant information. Selecting only the necessary columns is a game changer in SQL. Here is why it is so important. Improved readability, focused queries produce cleaner outputs, making it easier to analyze or share results. Better performance, retrieving fewer columns reduces the amount of data your database processes and transfers, speeding up queries, especially with large data sets. Resource efficiency, in production environments, minimizing data transfer saves bandwidth and system resources, which matters for applications or reports. Here is your hands-on challenge, run the select name, city from names query in your database. Then, experiment by selecting different column combinations, like just name or name and ID. You have mastered selecting specific columns, and now it is time to take your queries to the next level by filtering rows with the where clause. This is where the magic of SQL really shines, letting you zero in on exactly the data you need. Get your SQL editor ready, because you are going to run these queries yourself and see the results come to life. The where clause is your tool for retrieving only the rows that match a specific condition. It acts like a gatekeeper, filtering the dataset so that only the rows meeting your criteria appear in the output. This is essential for working with real-world data, where you often want to focus on a subset of records rather than everything in the table. For example, let us say you only want to see people in our names table who live in New York. You write. Select name, city from names where city equals New York. This command tells the database to check the city column and return only the rows where the value is New York. If your names table includes a record like Alice, New York, the output will show just that row. Compare this to select name, city from names without the where clause. You will see how where narrows down the results to exactly what you need. Why is the where clause so powerful? It lets you extract meaningful insights by focusing on relevant data. For instance, in a business database, you might use where to find customers who made purchases above $100 or employees hired in the last year. Without where, you would be stuck sifting through thousands of irrelevant rows, which is inefficient and overwhelming. Here is a key technical point: the where clause is processed early in the SQL execution order, right after the from clause and before operations like sorting or aggregation. This means it filters the dataset at the start, reducing the number of rows the database needs to process. For example, if your names table has 10,000 rows but only 50 are in New York, the where city equals New York clause ensures only those 50 rows are passed to the next steps. This early filtering boosts performance. Fewer rows mean faster queries, especially with large data sets. Saves resources. Less data is processed and transferred, which is critical in production environments. Improves clarity. Your queries stay focused, making them easier to read, maintain, and debug. Run the select name, city from names where city equals New York query in your database. Then, experiment with different conditions, like where city equals Chicago or where name equals Alice. If your table has other columns, like ID, try filtering on that, such as where ID is greater than 1. By mastering the where clause, you are unlocking the ability to ask precise questions of your data, which is at the heart of SQL. Whether you are analyzing sales, managing inventory, or exploring customer trends, where makes your queries efficient and insightful. Let us pause and bring it all together with a visual. This slide shows a screenshot of my Postgres screen, displaying the 3 types of select queries we have explored so far, side by side with their outputs. It is your chance to see how these queries work in action and compare their results to understand query refinement. Take a close look at selecting all columns using select asterisk from names, which pulls every column, like ID, name, and city, and all rows from the names table. Selecting specific columns with select name, city from names, showing only the name and city columns for a cleaner, more focused output. Filtering rows with select name, city from names where city equals New York, displaying only the rows where the city is New York. Seeing these queries together paints a clear picture of how we can refine our SQL statements to be more effective and efficient. Notice how each query narrows the focus, from all data, to specific columns, to specific rows. This progression is key to writing smart queries that save time, reduce clutter, and deliver exactly the insights you need. Your turn. If you have Postgres or another SQL tool open, try running these 3 queries yourself and compare your outputs to the screenshot. Do they match? If you are seeing different results, check your table's data or query syntax. Pause the video to experiment, and think about when you would use each type of query in a real project. This visual comparison is a great way to solidify what you've learned. You have learned how to select specific columns and filter rows with where. Now let us control how your results are displayed with the order by clause. This is your chance to make your data look exactly the way you want, so fire up your SQL editor and follow along to sort your results like a pro. By default, when you retrieve data from a table, the database returns records in an unpredictable order, often based on the primary key or the table's natural storage. But in real-world scenarios, like reports, leaderboards, or dashboards, you need to control the order to make the data meaningful. That is where the order by clause comes in, letting you sort results based on one or more columns. For example, to sort the names table alphabetically by name in ascending order, A to Z, you would write: select name, city from names order by name ascending. Go ahead, type this query and run it. This command sorts the records so names appear from A to Z, or as some say, A to Z or A to Z. If your table has records like Alice, Bob, and Carol, the output will list Alice first, then Bob, and finally Carol, along with their cities. Here is a handy tip: ascending order is the default for order by, so you can skip the ASC keyword and write select name, city from names order by name. Run this query too and compare the results. You will see it is identical to the previous one: Alice, Bob, Carol in A to Z order. The ascending is optional, but as we will discuss, including it can make your intentions clearer. Want to reverse the sort to descending order, Z to A? Use descending. Select name, city from names order by name DESC. Try this query now. It will list Carol first, then Bob, and finally Alice. The DESC keyword flips the order, which is perfect for rankings like top scores or most recent dates. Why is order by so important? Sorting makes your data more usable and professional. Imagine creating a customer report sorted by last name, a leaderboard ranking sales by amount, or a dashboard showing recent orders first. Order by ensures your results are presented in the order that best serves your audience, whether it is for clarity, analysis, or visual appeal. From personal experience, I recommend always including ascending or descending explicitly, even when ascending is the default. Why? Not everyone knows that ascending is the default, and even those who do might not immediately recall it when reading your query later. To make things crystal clear, I also add a brief comment, like --AZ for ascending or --ZA for descending. For example, select name, city from names order by name ascending, semicolon, space, --AZ. Yes, it is a bit more typing, but that is what comments are for, making your code easy to understand for teammates, future you, or anyone else who reads it. A small clarification like this can prevent confusion and save time, especially in collaborative projects or when revisiting queries months later. Trust me, your future self will thank you. Your hands-on challenge: run all three queries. Select name, city from names order by name. Select name, city from names order by name ASC. And select name, city from names order by name DESC. In your database, compare the outputs and confirm how the order changes. Then, experiment with sorting on a different column, like city, as order by city ASC. Mastering order by gives you control over how your data is presented, making your queries more polished and purposeful. Whether you are building reports or analyzing trends, sorting is a skill you will use constantly. So far, we have worked with a single table, but real-world databases often spread related data across multiple tables to stay organized and avoid redundancy. To bring that data together, we use join operations, and today we dive into one of the most common types, the inner join. Get your SQL editor ready, because you are about to combine tables like a pro in this hands-on segment. An inner join links two tables based on a common column, pulling only the records that match in both. Let us use an example with two tables, names and ages. The names table has columns for ID, name, and city, while the ages table has ID and age. The ID column is the common key that connects these tables, allowing us to match records. To combine data from both tables in a single query, you write: select names.name, names.city, ages.age. From names. Inner join ages on names.id equals ages.id. Go ahead, type this query into your SQL editor and run it. This statement joins the names and ages tables using the ID column. The inner join ensures that only records with a matching ID in both tables appear in the output. For example, if names has a record for Alice, ID 1, New York, and ages has a matching record, ID 1, 25, the result will show Alice New York, 25. If a record exists in names but not in ages, or vice versa, it is excluded from the results. Why is inner join so crucial? In relational databases, data is split across tables to minimize duplication and keep things tidy. For example, storing names and ages in separate tables avoids repeating city data for each age entry. Inner join lets you combine just the data you need, like creating a report with names, cities, and ages, without redundant storage. This is a cornerstone of working with relational databases, whether you are building applications, analyzing data, or generating insights. A key performance tip: the from clause, where joins happen, is processed early in SQL's logical query execution order, before where, group by, or order by. This makes it the ideal place to filter data, as it reduces the number of rows early in the process. For example, you can add conditions directly in the on clause to limit the joined data set, like on names.id equals ages.id and names.city equals New York. This filters out non-matching rows or irrelevant data before the tables are fully combined, saving processing power. While the where clause also filters, it runs after the join, meaning more rows might be processed unnecessarily. By pushing filters into the joins on clause when possible, you optimize performance and keep your queries lean. I have included an extra sheet on filtering in joins, which you can find at the end of this video. Let us take a moment to visualize the power of sorting and joining data with a screenshot from my Postgres screen. This slide showcases the three SQL queries we have just explored, displayed side by side with their outputs. It is your chance to see how these commands shape your results and make your data more meaningful. Here is what you will see. Sorting with order by. The results of select name, city from names order by name ascending and select name, city from names order by name descending, showing how records are organized in ascending, A to Z, and descending, Z to A, order. Notice the difference in how names like Alice, Bob, and Carol are arranged. Combining tables with inner join. The output of select names.name, names.city, ages.age from names inner join ages on names.id equals ages.id, illustrating how two tables are linked based on a shared ID column to create a unified data set, like pairing Alice's name and city with her age. This visual comparison highlights why these operations are essential for working efficiently with SQL. Sorting with order by organizes your results to make them clear and professional, whether for reports or dashboards. Joining tables with inner join lets you combine related data from multiple tables, enabling richer insights without redundancy. Together, these techniques transform raw data into actionable information. Your turn. If you are following along in Postgres or another SQL tool, run these three queries yourself and compare your outputs to the screenshot. Do the sorted orders match? Does the inner join combine the tables as expected? If your results differ, check your table data or query syntax. Pause the video to experiment, and think about how you would use these commands in a real-world project, like sorting a customer list or joining sales and product data. Until now we have built a strong foundation for retrieving data with SQL. We started with basic select statements, then learned to refine queries by selecting specific columns to focus on relevant data, filtering rows with where to target specific records, sorting results with order by to organize outputs, combining tables with inner join to merge related data sets. Mastering these core concepts is your key to unlocking the power of SQL databases, whether you are analyzing trends, building applications, or managing business operations. Each technique makes your queries more precise, efficient, and professional, setting you up for success in any data-driven role. On the next slide, we will dive into a more advanced SQL technique to take your skills even further. In this section, we combine data from the names and ages tables we created previously and insert it into a new table. Let us start by creating the new table to store the combined data. We create fields for ID, name, and city, from the names table, and age from the ages table. Create table combined. ID integer. Name variable character, 50. City variable character, 50. Age integer. In the next step we insert data from the names and ages tables into our new table. Insert into combined, ID, name, city, age. Select n.id, n.name, n.city, a.age. From names as n. Inner join ages as a on n.id equals a.id. This SQL statement inserts data into a table named combined, by combining data from the table's names and ages. The insert into combined part specifies that data will be inserted into the combined table. The select statement retrieves data from the names and ages tables. It pulls the ID, name, and city columns from the names table, and the age column from the ages table. The inner join combines the names and ages tables based on matching ID values. There will be only two names with ages in the combined table, Alice and Bob. These are the only two records with the same ID in both tables. Welcome to the final and most impactful segment of the SQL Do-It-Yourself video. We are diving into a game-changing technique that many SQL users overlook, filtering data in the join clause instead of relying solely on where. When working with large tables, think millions of records, this approach can save significant time and resources. Get your SQL editor ready, because you are about to optimize your queries like a pro in this hands-on lesson. Most SQL users filter data in the where clause, and that is fine for smaller data sets. But few realize you can filter directly in the joins on clause. This early filtering can make a huge difference in performance, particularly with massive tables. Let us break it down with a clear example and see why it matters. Filtering in the join. Consider our names and ages tables, where names has ID, name, and city, and ages has ID and age. To fetch only people who are 26 years old, you can filter in the join like this. Select names.name, names.city, ages.age from names inner join ages on names.id equals ages.id and ages.age equals 26. Go ahead, type this query and run it. Here is what happens. The database starts the inner join, matching rows where names.id equals ages.id. The on clause also filters for ages.age equals 26, so only rows with age 26 are considered for the join. If there is no matching ID or the age is not 26, as Bob and Carol have different ages, those rows from names are excluded entirely, as inner join only keeps matching records. For example, if only Alice has age 26 in the ages table, the output will show just her record, like Alice New York, 26. Non-matching rows are filtered out before the join completes, keeping the dataset small from the start. Filtering in where instead. Now, let us try the same goal using where. Select names.name, names.city, ages.age from names inner join ages on names.id equals ages.id where ages.age equals 26. Run this query too and compare. The result is identical to the join filter, only Alice's record appears if she is 26. But the process differs. The database first joins all matching rows from names and ages based on names.id equals ages.id, creating a larger temporary dataset. The where clause then filters this joined dataset to keep only rows where ages.age equals 26. Why does this matter? For inner joins, filtering in on versus where often produces the same result, but the performance and intention differ significantly. Filtering in join, on. The database filters rows before completing the join, reducing the number of rows early. This is faster with large tables, as fewer rows are processed. Filtering in where. The database joins all matching rows first, then applies the filter. This can be slower, as it processes more data before discarding irrelevant rows. With millions of records, filtering in the on clause can save seconds or even minutes by minimizing the dataset upfront. It is like packing only what you need for a trip instead of lugging everything along and sorting it later. Key takeaways. Filter early in join. Use on, as in on ages.age equals 26, to reduce the dataset before joining, boosting performance with large tables. Where for post-join filters. Use where when you need to filter after joining, especially with conditions involving multiple tables or complex logic. Same result, different efficiency. For inner joins, on and where filters may yield the same output, but on is often faster for single table conditions. Think like the database. Understand SQL's execution order, from /join first, then where, to place filters where they are most efficient. Your hands-on challenge: if you have names and ages tables, run both queries mentioned earlier and compare the outputs. Then, experiment by changing the filter, like on ages.age equals 30 or on names.city equals New York. Here are some tips to keep you on track. Qualify columns. Always use table.column, like ages.age, in joins to avoid ambiguous column errors. Single quotes for strings. Write on names.city equals quote New York quote, not New York without quotes, to avoid syntax errors. Test with small data first. Use a small dataset to verify your query before running it on millions of records. Mastering filtering in joins gives you a performance edge, making your queries faster and more scalable, crucial skills for real-world database work. Whether you are optimizing reports or handling massive data sets, this technique will set you apart.